This topic is Introduction to Derivatives. Okay, derivatives is the slope of tangent line. If you remember, what was the tangent line? If we have some graph, the slope of this. Let's say this is point X. You want to find the slope at that point, right? What will you do? Choose a very too close point. If this is X, I choose a very close point to X, like what? X plus H, and X plus H gonna be very small, close to 0, right? So then I say F the y2 minus y1. F of X plus H, the y value at the second point, minus the y value at first point divided by this x plus h minus x, right? You will have h. Since h is very small number, I'm taking the limit of this, then h go to 0. Then this is gonna be slope of your tangent line if you calculate that. We call this one derivative. Derivative of f of x. To show derivative, you put a prime on the top of that. If someone asks you what is the derivative, you say a slope, instantaneous rate of change, or a slope, or slope of tangent line. Okay, now I'm going to use the definition of that to take a derivative of x equal to x power 2. So that's the f prime, since f x plus h. So first I need to find f of x plus h, right? Simply f of x plus h means instead of x here, you put x plus h. See, instead of the x here, you put x plus h. So here, f of x plus h, then going to be x plus h power 2. F of x is x power 2 divided by h. If you put h is equal to 0, it gets 0 over 0. So what you do is you need to simplify. So you x plus h power 2, the first one power 2 plus the twice of the first multiplied by second one, 2xh. The last one power 2, h power 2, minus x. And you see x2 and x2 cancel. Then you can factor out h from numerator. It's going to be h is 2x plus h, right? We have h in denominator. And here we have a still limit. H go to 0. See, h and h cancel. Now the problem is solved. You just instead of the h plus 0, and here you have 2x plus instead of h equals 0, which is equal to 2x. So derivative of x power 2 is equal to 2x. Now, the same way you do it for fx power. So again, the definition of the derivative is f prime is equal to limit of fx plus h minus f of x divided by h. What do? You need to find f of x plus h, right? What is that? Again, instead of x, you have x plus h. Means here, instead of the x, you put x plus h power 3. Now here, instead of x plus h, I put x plus h power 2 minus x power 2. If you x go h going to 0, is h going to 0? Make sure. That h going to 0. So you expand it. The first one power 3 times the first power 2 multiplied by the second one, 3 times now the first one multiplied by second one power 2 plus the last number power 3. Here's h power 3. As you see, the x power 3 here cancel. You have that. You can factor out h. See, you have 3x power 2 plus 3xh plus h power 2 divided by h. Limit h go to 0. H and h cancel. And instead of the h, you put 0 this time and this one getting 0, right? It's just 3x power 2. You put 0 here instead of x, you get 0. You put 0 instead of h power 2, you get 0. So the answer is 3x power 2. So the derivative of x power 3 is 3x power 2. Okay, now for the worksheet, let me just explain. So the f prime is the limit of f of x plus h minus f of x divided by h. This is the first principle definition of the derivative. When we ask you to take a derivative using first principle definition, use that formula. So the derivative of the function, you can show it as f prime, or you can say it is y prime, or change of y divided by change of x, rise over run. This is a slope, right? The definition of the derivative is a slope. Or sometimes you can show it d of fx divided by dx. All of them meaning the same thing. So if the derivative doesn't exist at the point of the curve, the function is non-differentiable. If your function is discontinuous, of course, it's not differentiable and other cases. So I want you to do question 1. Question number 2 IV C. Number 3, we do one of them. Let's just do the second one for number 3. So number 4, question number 4 you do. Also, you can do number 5 and do number 5D. Okay, yeah, that's it.